Okay, what's up guys? Here's a review for your test tomorrow. It's not a lot of work. You just got to know what you're doing. You're gonna watch this video. It's not a terribly long video, and then you're gonna do the other packet that was with it, and you can come back to my desk and ask me questions if you act, because you're not really gonna know what you do. You have a good idea, but then until you do it on your own, you don't really know for sure what you get, what you don't. Okay, write a function for the table. There's two variables, m and g. I need to see both of these variables. Both of them need to be in the equation. Okay, you go over here, you write g equals. Okay, you want to go under here. I need to see that. Where's your g start at? 11.2. Okay. Usually if I look over here, there'll be a 0, so that tells me where to start at. Then what's happening? Am I adding or subtracting? Well, it's getting lower, so that would be subtracting. To find what you're subtracting, well, just subtract the numbers one by one. Boom. 1, 1. Okay, so it's a linear function, okay? So you put 1. Now, go look over here and figure out what you're subtracting, because you see, you're going to underline the 1 because that's a ratio. You're subtracting 1, but that's every time the miles change by what, okay? Well, let's see. Okay, let's go 51, and always start at your highest number when doing this. Minus 34. 34 minus 17, 17 minus 0, okay, 17. So the ratio is 1 to 17. That goes, you're subtracting 1 every time this goes forward by 17. Okay, now you need to put the m variable. I said you had to have two variables, so you put the m behind right with the 1, okay. That's your answer. Now I'm going to review that again, how I get to the answer, okay. So g equals, you start at 11.2. Then you can see you're subtracting. The g is subtracting. To figure out what you're subtracting, just 1. And usually when you figure it out, you want to just go one by one. Okay, I'm subtracting 1. But then I'm underlining the 1 because that's going up by 17. Okay, and to discover that's going up by 17, you go 51 minus 34. 34 minus 17. 17 minus 0. Okay, 17. Okay, and again, I need to see the variable because you're subtracting 1 every 17m. Okay, is how that works. That's your answer. Okay, to whether the relationship's linear or nonlinear, you're either writing one of two things. Your x is a given now, and just subtract, okay? So you go 14 minus 11, 3, 11 minus 8, 3, 8 minus 5, 3. Yep, that one's linear. The linear pattern was never disrupted. Okay, 72 minus 12. Okay, that obviously I'm getting different things, so that's nonlinear. Okay, domain range. I want to buy limited edition coins for $22 each. There's a limit of 8 coins for a customer. Find the domain range of the relationship, and then is the function continuous or is it discrete? Okay, make your table, and I have the 2xy table. Now, money is always y. You should know that by now, okay? X is coins. So you put coins, money. I'm going to buy a coin. I buy 0 coins, I pay $0. If I buy 1 coin, I'm $22. If I buy 2, add 22 onto that, that's 44. If you buy 3, you add 22, that's 66. Okay, then I make continuation dots. The limit's 8, but it's 8 coins. Okay, go put it under coins. Okay, now to figure out your money limit, okay, if there's a limit for coins, there's a limit of the money you can spend. So you take your 8 times, what does a coin cost? Okay, what's it going up by every time? 22. So 8 times 22. Okay, $176. Okay. So the domain 0 to 8, I can buy between 0 and 8 coins, and then the range are 0 to 176. Now it's continuous or discrete. Now remember, I'll put a decimal here, 2.5. Can you buy 2.5 coins? Is that even possible? No, so decimals are not included. Neither are fractions within your domain, so it's discrete. Okay. Okay, graph the equation. Now when you graph this, okay, at this point in time, draw a wall, dot it, don't circle it, because we're going to put some numbers in for x, okay? And we can put them any number we want, but let's get 5 numbers, -2, -1, 0, 1, 2. Then that gives me a good representation of what happens on the graph. So I've got 2. Again, I'm going to exhibit it on my calculator. So we have 2 times, then x, the first substitution is -2, and then we subtract 4, -8. Okay, then I go 2 times, the next substitution is -1, and then subtract 4, -6. 2 times 0 minus 4 is -4. You can see the linear pattern developing, okay? 2 times 1 minus 4, -2. And then 2, and I substitute 2 minus 4, 0. Okay, this is the x, this is the y. Okay, so you got positive, positive, because you got 0 and then 1, 2, 3, 4, 5, 6, 7, 8, 9 on the lines. Okay, and then positive here because 1, 2, 3, 4, 5, 6, 7, 8, 9. Over here you got negative positive because you're going negative for x. So -1, -2, -3, -4, -5, -6, -7, -8, -9. Okay, down here you're negative, okay, because -1, -2, -3, -4, -5, -6, -7, -8, -9, okay? And then I'm good. And over here is positive, negative. You don't need to make the positive negatives. You don't need to draw the numbers if you don't think you need to. You got to get the line graphed accurately. So -2 on x is right here, and then -8 on y is down here. -1, -6. 0 on x, it's right in the middle, and then -4 down here. You can see it, the linear pattern developing. 1, -2, I go 1, because x is 1, there's 1 on x, and then -2 on y is here. And then 2, 0. So 2 on x is here, 0 on y would be right there. You can see the lines just developing. Now, you connect them because it's a continuous graph. You can put decimals and fractions in for x. There's nothing stopping you, okay? We just don't do it because it would take forever. So what we do is we just connect them, the in-between parts. That's continuous. Okay, easy. Tell whether the graph's a function. We're going to make a vertical line. If we can make a vertical line through 2 points in a row, then it's not a function. No, just 1, 1, 1, 1, 1, 1, 1, 1, 1. That's a function, okay? Okay, next one. 1, 1, 1, 1. Okay. Oh, 3. That's not a function then. Okay, now these aren't points. This is a continuous graph. By the way, these are discrete graphs because there's just random points. This is a continuous graph. It's all a bunch of points. It's just connected. I think if I draw a straight vertical line, it crosses 2 points. So that's not a function. If it crosses 1 point, it is a function. Okay, Torah, the relation represents a function. So you got xy, 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 xy. Now I'm going to put domain and range. Domain's negative, the x's, -2, 0, 4, 5. Then the range, you got 0.5, 2.5, 6.5, and 2.5. Any repeats in the domain? I don't think you do, so that's a function. It's like that vertical line. If you can't do repeat, the same deal. Domain and range. So 6, 4, 6, and 5. Then right below it, I'm going to go 5, 3, 4, 8. Okay, I have repeat values of 6, and they match up to different range values, so that means it's not a function. Okay, then the last one, you're writing a rule just by reading the little paragraph. The volume, remember I need to see 2 variables. If I don't see 2, it's wrong. Volume equals remaining in a 243 cubic foot pile of gravel decreases by 0.2 cubic foot with each shovel S of gravel spread in a walkway. Write a function rule to represent the situation. So you got 243, and then you're decreasing by 0.2. But you're decreasing by 0.2 each shovel, okay, S. That's it, okay. Okay, do the other packet and show it to me when you got it done so I can check. It's not a gotcha, okay? I'd just like to check it, see if you know what you're doing.